Thinking Aloud. Conversations on the leading edge of knowledge and discovery with parapsychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. This is part 4 of our 6-part series on consciousness and the brain with Professor Stuart Hameroff, who is with the Banner University Medical Center at the University of Arizona, where he's a professor of anesthesiology and psychology. He is also the co-founder and director of the Center for Consciousness Studies at the University of Arizona and is author of Ultimate Computing, Biomolecular Consciousness and Nanotechnology. Welcome again, Stuart.
Thank you, Jeffrey.
It's a pleasure to be with you. Now, we've covered a lot of ground in the first 3 parts of this 6-part series. We've talked about microtubules, and we've talked about the role of quantum physics and consciousness. Let's go in a little more depth into your work with Sir Roger Penrose, with whom you co-authored your Orch OR theory of consciousness.
Yes, well, as I said, I've been studying microtubules as information processors at a level inside neurons, taking the capacity of the brain to a much greater level, much greater than artificial intelligence people were willing to acknowledge, in which one neuron was 1 bit. In this case, one neuron had something like 10 to the 16th bits per second or operations per second. But it didn't explain consciousness. And somebody challenged me on that and suggested I read a book by Sir Roger Penrose, The Emperor's New Mind, which I did. And I was really blown away by it. And after reading it, I concluded from his mechanism of quantum collapse, he had a mechanism for consciousness, but didn't have a structure. I had a structure that could work at the quantum level in microtubules, but didn't have a mechanism. So it occurred to me that we should team up and perhaps combine our efforts. And so I wrote to him and sent him some papers that I had written, send a link, well, we didn't have links in those days, but a reference to my book, Ultimate Computing, and several articles, and mentioned I would be in England for a conference in Brighton. And I was very pleased to hear back from him, inviting me to visit him at Oxford, which I did. And so he met me at the train station, and we went to his office in the Mathematical Institute. It was a fairly large office, but very cluttered in an organized way. Shelves, tables, chairs, everything was filled with stacks of papers and so forth. And he asked me about microtubules, and I brought a copy of my book and went through all the images so he could see what they looked like and so forth. And he asked a lot of questions. He was particularly interested in the Fibonacci geometry of the microtubule helical winding pattern. Fibonacci is a pattern, the sum of subsequent numbers 1, 2, 3, 5, 8, 13, 21 that occurs throughout science and biology and nature. And it's kind of some kind of platonic value or something that Roger is very interested in. And microtubules have this Fibonacci series. So he was very keen about that. And I did most of the talking as he just asked a bunch of questions. Yeah. And this went on for about 3 hours.
We should mention for our viewers who may not know that now you're in the office with the man who pretty much is the pioneer of the theory of black holes.
Yes, he and Stephen Hawking developed the theory of black holes. Hawking was actually his student. Roger was his professor. And they worked on black holes and singularities in general and Einstein's equations for general relativity. Yeah. Roger is also famous for geometry, tiling planes in patterns that never repeat, a 5-fold symmetry that he predicted that was later found in nature. And a lot of contributions in gravity, quantum gravity, understanding gravity, and attempting to link relativity, general relativity, and quantum gravity, and quantum physics, which would be the answer to quantum gravity and the structure of the universe, because these two great theories don't really jive. And it's at the interface where he works, and actually brings in consciousness to help solve the problem.
So, as did many of the great physicists of the 20th century.
Well, they didn't. The ones who brought in consciousness as a way to cause collapse of the wave function. And like Schrodinger's cat, the superposition persists until someone actually looks at it, a human conscious observer or conscious observer. But Roger turned that around. He said collapse isn't caused by consciousness, but collapse causes consciousness, or collapse is consciousness. Whenever the superposition, which is a separation in the underlying structure of the universe, reaches a critical threshold given by one very simple equation, the uncertainty principle, which is the kind of the predominant equation in quantum mechanics, the Heisenberg uncertainty principle or the indeterminacy principle, that the two possibilities or multiple possibilities would reduce or collapse to one or the other, and that this would give forth or emit a moment of consciousness, a subject of kind of a quantum of consciousness.
I believe you call it a proto-consciousness.
If it happens kind of randomly here, there, everywhere in the universe, willy-nilly, without being connected, yes, it would be proto-consciousness. What needed to be done was to show how that could occur in the brain in a way that avoided random interactions and connected with other moments of consciousness with meaning to give coherent, full, rich conscious experience that we have.
Now, I presume that's where the orc in Orch OR comes from, orchestrated.
That is correct. We were trying to think of a term, and we had met several times, and we were spending some time together in Denmark, where I had done my sabbatical, and Roger spends a lot of time, and we spent some time sharing a house. We rented from a Danish family on Lake Lyngby, and we were trying to think of a name for this, and orchestration came to me. And because I'd always wondered how Microtubules orchestrated the delicate dance of, or choreographed the delicate dance of chromosomes, and so I suggested orchestration, and Roger liked it a lot. In fact, he thought that he could have even used that instead of objective reduction, could have been orchestrated reduction. So orchestration implies how these proto-conscious moments can be combined and unified in a meaningful way to give full, rich conscious experience. And for that, we needed microtubules.
Yeah. It also suggests to me that you're moving away from the idea of the brain and consciousness itself as a computer, but into the metaphor of the orchestra as a whole different way of thinking about the way the mind works.
Yes, it's taken another 20 years to get to that point, but that's exactly right. Everybody assumes the brain is a computer, just like mankind has always likened the brain to the contemporary information processing technology. The Greeks had the idea that memory was a seal ring in wax. Later in the 19th century, the brain was like a telegraph switching circuit. Freud had the unconscious boiling up like a steam engine overflowing. Carl Pribram had a hologram, which is actually, I think, coming back into favor, or should. And then the computer came along. And because the computer is so dominant in modern life and technology, it's kind of taken over. And with all the effort and money in computers and trying to emulate the brain, that's pretty much the dominant paradigm. But I don't think it's right. I think what you just said is more correct, that the brain is more like an orchestra. It's a multiscalar vibrational system. And a lot of people have shown this for EEG and upward in terms of scale, with a very fast EEG. And if you look at, if you take EEG and zoom in on it and look at the fine scale, you see self-similar patterns. It's almost like a fractal or a hologram with patterns repeating at different scales. But the problem is that they hadn't taken it inside the neuron to a deeper level where you get faster, smaller, and vibrations. So,
which is what you do with introducing the role of microtubules inside the neurons, which we could say are part of the cytoplasm or the skeletal structure that sort of holds a neuron together.
The cytoskeleton, yes. It's attributed to being the structural support of the cell, of all cells. Neurons being highly asymmetrical need the most extensive cytoskeletal structure. And it's interesting that in all of biology, the microtubules are arranged continuously and radially from the center of the cell outward, like spokes of a wheel, with a hub by the centrosome. And in axons, it's the same way. They all point outward, and with the plus end here and the minus end here. In dendrites, which are the parts of the neuron that collect and integrate information, which is where other evidence suggests consciousness occurs, from anesthesia generating and also where EEG is generated. The microtubules are different. They're short and interrupted in local networks. Now, if you wanted structure, if you wanted skeletal support, you wouldn't break your girders into little pieces and make them into small networks. A skyscraper wouldn't last that long if you had interrupted girders. But in dendrites, the microtubules are interrupted, and in these mixed polarity networks, which we showed in a paper by Steen Rasmussen et al. in about 1990 that this is ideal for information processing. So I think that kind of suggests that the kind of consciousness we have comes from dendrites and soma, and when the threshold is reached for collapse, consciousness happens, and that also correlates with the threshold for triggering action potential or a spike down the axon. Now, most people look at the spikes as the information processing, but I think they're kind of the messengers conveying the results of a conscious process down to the next synapse to move your arm or say a word or whatever.
So if I can summarize where we are now, it suggests to me that the Orch OR theory is talking about several layers of computing that do take place in the brain. The neural spikes being one layer, the information processing inside the microtubules that in your first book you think of that as a biomolecular computer. And then underneath that, at the quantum level, is where consciousness sort of exists, and so we can become aware of what's going on in that whole structure.
Yes, we think that the awareness, the subjectivity, the qualia, the solution to the hard problem, come from a process in space-time geometry, the very structure of the universe. And this was Roger's one of his great contributions. And the idea that these self-collapses result in a moment of consciousness, putting consciousness at the same level, fundamental level of the universe as things like mass, spin, charge. How would you define or explain electrical charge? It just is. Or a spin on an electron, magnetic forces and so forth. So it's that consciousness is intrinsic to the universe and is a kind of a quantum entity or particle that's part of the universe and is probably always been there.
Now, you've mentioned mass, spin, and charge. Would you say that consciousness is akin to time and space?
Well, time and space, we think of it, or Roger thinks of it in terms of space-time geometry, four-dimensional space-time geometry. There's a lot of physics nowadays that utilize multiple dimensions, string theory, for example, M theory, and the multiple worlds and all that. But he sticks with four-dimensional Minkowski-Einstein space-time geometry. But instead of extra dimensions, bringing in these extra factors, extraneous factors like consciousness, as some people do, it's occurring at a different scale in the one four-dimensional universe that we have. So we don't need all these extra dimensions, which are mathematical conveniences, I would say, and Roger would say. So it's consciousness is built into the universe, and but it comes from different scales. So as you go down in scale, faster, smaller, more intense conscious experience.
Oh, okay. I'm not sure I felt like I got an answer to my question, though. Is consciousness equivalent to time and space, or would you say it's derived from or emerges from time and space?
I'd say it's a property of space-time geometry.
Okay.
Now, time is a funny thing because, space is a funny thing too, but in Minkowski space-time geometry, there's no reason that you couldn't go backwards and forwards in time, just like you can go forwards and backwards in space. So there's a mystery about whether we can go backwards and forwards in time. In the quantum world, going backwards in time is no problem. Time is symmetric in the quantum world. And it could be that the flow of time that we experience is actually due to consciousness occurring and ratcheting forward, because a collapse is an irreversible moment. So it moves you forward and you can't really go back. Now, you can go back in time if you're looking at things that haven't yet collapsed. So it's possible to have backward time effects, as we think happens in entanglement. But I would say that consciousness is a property of space-time geometry and moves time forward. And the rate at which it moves forward depends on how many conscious moments you have per second or per whatever. So, for example, if we're having normally 40 conscious moments per second, 40 hertz gamma synchrony, which most people would say, that would be normal. Now, if you're in an altered state, let's say you're in a car accident, God forbid, and the car is spinning, people often report, well, time slows down. And it could be that you're in a condition where you go from, say, 40 to 80 to 100 to 200 moments per second. Mm-hmm. You're having more conscious moments per time, so the external world appears slower to you. Mm-hmm. And this could be time dilation. The great athlete Michael Jordan was asked, well, how can you be such a great player? And he says, when I'm playing well, the other team is in slow motion. Mm-hmm. So he's having more moves or more conscious moments per time than the other guys.
Mm-hmm. So what you're suggesting now is that certain extraordinary states of consciousness, like athletic performance at a very high level, can now be accounted for by your theory.
Yes, different states basically depend on higher frequency, mm-hmm. and by the one equation, E equals h over t, the indeterminacy principle, h is Planck's constant and t is time. So as time gets smaller, as you have more conscious moments, you need more E. So, and that also relates to the intensity. So mm-hmm. more mass, more superposition, more intense experience. So I think in altered states, you go faster, involve more of the brain. So under normal circumstances, say 40 times a second conscious moments, we're only using a small fraction of our brain going into superposition. But as we have altered states, we're using more and more and more. And actually, it's possible to go up to a fairly large percentage of the brain with extreme conscious moments as you go deeper into mm-hmm. the quantum world and into space-time geometry.
Mm-hmm. Well, let's return back to your meeting with Sir Roger Penrose. You're in his office at Cambridge.
Oxford.
At Oxford, Oxford University. And this is in the early 1990s?
Yeah, 1991 or 92, I think. Mm-hmm. And he said he was going to a conference on consciousness at Cambridge with Pat Churchland and Daniel Dennett and some other big names in philosophy. And I said, that sounds interesting, but I had to go to a different conference, not that I was invited anyway. And so we said goodbye, and he thanked me for coming, and I thanked him for listening. And I didn't really think much would mm-hmm. come of it, although I certainly hope something would. And I went to my meeting and went to the continent and came back about 2 weeks later. I was having dinner with a friend. He said, guess what? A friend of mine went to this conference at Cambridge on consciousness, and Roger Penrose was talking about you and your microtubule ideas. And I was thrilled. I was, mm-hmm. wow, that's really cool. And shortly after, I got invited to a meeting in Sweden above the Arctic Circle, a closed meeting of just scientists. And, mm-hmm. and Dan Dennett was there, and Petra Storig, and Roger, and obviously he had gotten me invited. And so we began to develop our theory. We began to became friends. He and his wife Vanessa, and we went for walks. It was the midnight sun. It was just a charming mm-hmm. environment. We went skiing at night, mm-hmm. and we just had a great time. And at that time, I was planning the first interdisciplinary conference toward a science of consciousness in Tucson in 1994, and I mm-hmm. invited him, and he graciously accepted, and so he came to the first Tucson conference and was a key keynote speaker.
And those conferences have been an annual event now for over 20 years.
They have, and last year in 2014, we celebrated the 20-year anniversary conference, which is the reason for this shirt.
And yes, that we're both wearing.
We're both wearing.
I was there.
You were at the first one, that's right. And you were doing interviews very mm-hmm. similar to this. And you were, a leader ahead of the curve, as usual. And it was a great event. It was, prior to that time, people had been there were some conferences in philosophy on consciousness. There were mm-hmm. some conferences in Eastern spirituality and maybe some neuroscience. But nobody had brought all these various approaches under one umbrella, which I thought was mm-hmm. necessary. And so we had the first conference. The internet had just appeared, and it was a great success.
Mm-hmm. Well, since we're talking about that conference, let me share with you a moment that stood out for me because it happened when I participated in a group discussion, and you had very graciously and generously invited a number of parapsychologists there, which is my own background. I actually have a doctoral degree in parapsychology.
Yes, I know that.
And many of the other researchers there were a bit put off, frankly, by our presence. And I think some of them said, and I think they felt they were being generous, actually, is that, well, first we have to solve the problem of consciousness, then we can deal with the paranormal. And I stood up and said, no, I think you guys have it backwards. First, you have to recognize the paranormal and deal with the data. Then you can begin to address the problem of consciousness. And I wonder how you feel about that.
I agree completely, because if parapsychology is true, and I believe it is true, and in fact, I think the evidence from parapsychology is probably more rigorous in terms of statistical analysis because of all the grief you guys get from the mainstreamers who don't want to believe it, that tells you something very important, that consciousness is non-local. And if it's non-local, it almost has to be a quantum effect. I mean, electromagnetic waves only go so far. I think it has to be quantum entanglement, which gives you non-locality in space and in time, even backward time effects. And backward time effects are an extremely important clue, I think, to this whole puzzle of conscious experiences. The experiments of Ben Libit, for example, who was at the first conference and who Roger had quoted in his book due to his backward time effects. And so they got to meet.
Now, we better let our viewers know what those experiments are because they're very important.
Yes. Benjamin Libit was a neurophysiologist at University of California, San Francisco. And in the late 1970s, he did experiments with Bertram Feinstein, a neurosurgeon. And for example, he would have a patient, Feinstein did some cases awake neurosurgery. So you can numb up the skin, the scalp, and the gallia, the lining over the bone, and the meninges, and actually operate on the brain while the patient's awake. And Libet came to the operating room and did experiments. For example, if you had the brain area for the little finger, you could stimulate the finger and record from here and ask the patient, when do you feel it? And he had a very sophisticated way of deciding when, because by the time you utter the words, I feel it, that's a long time. So he had a clever way to do that. And you might think that if you stimulated the brain directly, you'd get an immediate response. Oh, I feel it. And that if you stimulated here, it would take a delay to get to the brain. What he found was pretty much the opposite, actually. If you stimulate here, it takes 30 milliseconds, and you get a spike, what's called an evoked potential. If you stimulate here, it took 500 milliseconds, a half a second, which is a long time in the brain. And then he did some other experiments with the thalamus, which showed that if you got the evoked potential and got the ongoing activity, but only for, say, 100 milliseconds, there was no consciousness at 30 milliseconds. He concluded that somehow there needed to be this evoked potential and then 500 milliseconds, or at least several hundred milliseconds of ongoing activity afterwards to have the experience at 30 milliseconds. In other words, somehow the brain knew what was going to happen in the future. And he suggested that there was this backward referral of subjective information going from roughly 500 milliseconds back to the time of the
stimulus
of the evoked potential caused by the stimulus. And this is very important because it allows the possibility of free will. For example, if you and I are talking and I say something and you respond quickly back to me, the activity in your brain that correlates with what I said occurs after you've already responded. So the consensus in neuroscience and what they concluded was that you would respond, or we respond generally non-consciously and have an illusion of consciousness being in control after the fact.
Yes.
Rendering consciousness epiphenomenal. And as Huxley said, we're merely helpless spectators. Now, with backward time, you get around that problem. So it allows you to act consciously in real time and actually can explain a lot. And this kind of backward time effect has been popping up in neuroscience, parapsychology, quantum physics for many, many years. And it's kind of hushed in neuroscience. There's kind of a cover-up, which we hope to expose at the next conference.
Well, we're getting into some very profound issues, and I can well imagine that some of our viewers are scratching their heads and saying, here's a neuroscientist talking about backward time.
Yes. Well, in quantum physics, backward time is not a problem. The quantum erasure experiments, for example, that Anton Zeilinger's group has done, if a particle goes through two slits, it can either behave as a wave or a particle, depending on how you decide to measure it. And they showed that if you decide after the experiment has occurred, it affects what had previously happened. So in quantum physics, that's not a problem. And backward time may be necessary in entanglement. So if things are separated spatially and you make a measurement here and this one reacts instantaneously, Penrose and Ben Schumacher and others have suggested that the signal goes backwards in time to when the two were together and then forward here. And that would explain this so-called faster than light. It actually records backward time effects.
Yeah.
And this actually enables, if this is occurring in the brain, which it looks like it is, it allows the possibility of free will, because without this, we're always several hundred milliseconds behind. Yeah. We're living in the past, and that means consciousness is epiphenomenal. We don't really have any say or causal activity in the world. We're just kind of along for the ride.
We're never in the now moment.
Never in the now moment without this backward time effect, without quantum physics in the brain.
Well, you're addressing something very profound, because after all of our legal doctrines assume human free will, and conventional science seems to have very little room for it.
Yes, actually, there's a big debate about the law, and according to the mainstream view, consciousness doesn't have to, if you act impulsively or in real time, and there's not a lot of premeditation to let you consciously plan, it means you're acting non-consciously. My inner zombie made me do it, or my inner zombie did it. I didn't do it. And that's been used as defense, actually, and these debates go on. Now, I don't want to get it, I don't want to take sides in a legal argument, but I think this backward time does allow the possibility for us to act in real time consciously and exert causal efficacy in the world.
Stuart Hameroff, what a pleasure once again to be with you and to talk about in a scientific method, in a scientific manner, some of these issues that have previously, I think, mostly been relegated to philosophy. Thank you so much.
You're welcome. Thank you.
And thank you for being with us. Be sure to check your channel listings for part 5 of this 6-part series on consciousness and the brain.